Hello everyone, I am Mia, and today I'm here to tell you an intriguing story about working with a codebase which has blended two quite different technologies together. I'll share my personal insights on how to navigate through it, highlighting the advantages, struggles, and lessons learned along the way. The first framework I have an experience working with was Flask. I use it mostly for my hobby projects, but also for my diploma thesis. What I like about Flask is that it's very lightweight, very simple, and very easy to use. Then, I began working for a company that used Django. We were creating typical CRUD apps for our internal employees, and Django was great. It had all the things we needed, it worked quite well out of the box, it did not require any configuration, and moreover, there are lots of different tools in very rich Django ecosystems that we were using. And finally, I joined my current company where we use FastAPI, but in one unconventional setup that I want to talk about today, FastAPI with Django ORM. If we have a look at the current state of Python ecosystem, Django is the most popular framework. It leads the pack, it's used by 40% of responders, followed closely by Flask, 38%, and FastAPI, 25%, data from 2023. However, the interesting fact about FastAPI is its huge growth and massive adoption, rising from 14% in 2021 to 25% in 2023. So, what is FastAPI? What is this new framework some people are talking about? It's a newer framework released in December 2018. It's modern and it's flexible. It's built on the shoulders of two giants, Starlet and Pydantic. Pydantic is a Python library used for data validation, serialization, and documentation, and Starlet is a web toolkit. What it means basically is that you can take any of its components and you can use them independently. Starlet uses UVcorn and it implements ASCII spec. Now, the question is, how can we start with FastAPI? So, let's see some examples. This is the simplest example you can find. So, first we create an instance of the FastAPI class, which will be our main application. Then we define a route, and finally we create the endpoint that just returns message, hello world. Now, let's see how FastAPI leverages Pydantic for data validation. First, we create a base model class called item with some specific attributes, and we define here their types. Then, we create an endpoint that uses our Pydantic class as the response model. So what happens here basically is that if the data doesn't match the specified types, then an error message is raised. Let's see some example about database interaction. So first, we define a function in our CRUD.py file that basically just returns all objects of a model called item. Then, on the API layer, we can call our CRUD method, passing the inject database section and other query parameters. Okay, so now some of you might be wondering, but why? Why would you use FastAPI and, for example, not use Django or Django REST framework? So my experience is that most people and organizations use it because it's performant. And it's performant largely due to its asynchronous capabilities. Here we can see some benchmarks comparing different Python frameworks where we measure responses per second with 20 queries per request. You can visit the specified URL and you can check it on your own. You can tweak configuration and see how does it work with different databases, for example, different amount of requests. But basically, FastAPI consistently ranks as one of the fastest Python frameworks here on the 5th place. Above it is Starlet and UVcorn that it's built on. Then there is Routerlink, which is a framework I've never heard of, and it's not very famous. And after it, we can see some more frameworks, and then we can see Django here on the 14th place. And in one of the code bases that I am supporting, the reason why FastAPI was initially chosen was its performance. It's because we create a data visualization application, and that application fetches data from multiple endpoints, so there are a lot of I/O-bound tasks, and performance was the most important requirement. Another thing which is very nice about FastAPI, this is not the reason why people mostly use it, but it's a nice plus, is that it offers documentation of endpoints. So if you open your app and you go to /docs, you can explore and interact with your API directly. Alternatively, if you prefer a different style, you can go to /redoc and you can see the documentation in redoc format, which also utilizes the Open API specification. This feature it's possible to have it in Django, but you have to use third-party libraries. It's not built in like in FastAPI. There's one more thing about FastAPI that I really like, and that's dependency injections. So I read everywhere that dependency injections are really useful and that they are very nice, that help keep your code clean. But I struggled a lot with understanding how exactly. I understand the broad concept, but for me it was hard to find a place in my code base to say, okay, this is the line where I really see the difference it makes. So one day I was writing tests. And first I had to write a test for a function that fetches data from some external endpoints. It does something with the data. There's some business logic. So I started thinking how to do it. So the first thing you have to do is you have to mock your external responses, because it was a unit test and I didn't want to call the external endpoints. So I started, first I had to figure out where everywhere do I call external endpoints. And when you have a huge enterprise application, you have lots of layers, lots of different files. And then I also had to figure out what kind of response do I need there. And it was a very painful process, like who likes mocking? Because you have to figure out where everywhere you're calling these things and what is your response. And then I wrote the test, and then I had to write a test for another function, but this one was using dependency injection. And that's why I realized why dependency injections are useful. So let me show you an example. So here, let's say we have a service that fetches data from some external production API. And here's an example how you can use it. And here we have an endpoint that utilizes this service. So basically, each time the endpoint /fetch data is called, an external call is made. Now, how can we test it without calling the external endpoint in a very simple and easy way? So here's an example how our test might look like. First, we create an async mock object that has a return value. And if we want to swap our dependencies and use the async mock instead of the production service, we can call dependency overrides. And then we proceed to test it as usual. So basically, in just one line, we manage to swap our service with another. Another nice thing about dependency injection is that you can see them all at once. You can see what are all other services that your service depends on. And basically, it creates a very nice graph. So even before you start writing tests, you know how many dependencies you have, and you can prepare your test data. And I think this is a very nice pattern. I'm not seeing it used with Django, but I think it really helps you to keep your code clean, and it really helps you with writing tests. Another thing about FastAPI is its simplicity. I've worked for Django for a long time, and whenever I used admin panel, it was mostly just to update data, to delete something, or something similar. And I always use admin as is. And admin is great because you can just interact with your models there, basically, so it was great. One day, I was tasked with tweaking the admin panel. We had to add a button which on clicks invokes some custom script. Now, I'm not a front-end developer, but I'm sure I'm able to write a function that would invoke a custom script and create a button within 15 minutes, because that's a very common thing, right? Like buttons which do something on click are everywhere. So I thought, okay, this will be a very easy thing to do. So I started figuring out how does Django admin work. And to my surprise, I somehow thought it would be like front-end, where you have different components, and you see there all the properties and everything, so it's very easy to tweak anything. But then I realized that's not how it works. In order how does it works, you have to go to the documentation, read about it, you have to go lots of layers under it, check the source code, and that's because in Django, there are lots of things happening under the hood. And I think that's great. That's great if you want to use the things as they are. But as long as you have to tweak things, it's very hard to figure out what's happening under the hood. So basically, I spent a whole day figuring out how to add that one button. When I added it, I realized that it's there, but under another button that was already there. So I had to change its properties so it's moved somewhere else. And I also wanted it in a different color. And after it, I just decided to change my approach and do it in a different way, to invoke the script in a different way. And I think, as said, Django is great when you use things as they are, but sometimes you need to tweak things a lot, and I think frameworks like FastAPI can be a bit better because they're a bit more flexible, so you can customize them as much as you want. So now you might be wondering, so if you decide to use FastAPI for any reasons, or for projects that already use FastAPI, what ORM should you use? Is Django ORM commonly used with FastAPI? If you have a look at the most popular FastAPI open source projects on GitHub, like this one, for example, you'll notice that none of them use Django ORM. Most of these, in fact, use SQL Alchemy. So now you might be wondering, why? Why do we use Django ORM with FastAPI, or what benefits can it bring? One of the killer features of Django that I really like is its admin panel that I already mentioned. I think it's super useful when you have users who are, for example, not programmers. So, for example, you have support engineers or you have consultants, and they need to prepare some data, they need to change some data, delete something, update, and sometimes you don't want to give them an access to your database. Or maybe they are not technical enough and they don't know how to work with the database. So Django admin is really great. And in the codebase that I am working with, this was one of the biggest reasons why Django ORM was chosen, because of its admin panel. Django FastAPI doesn't have any built-in built-in panel when you use it with SQL Alchemy, for example. I know there are some third-party libraries, but even these third-party libraries are not as good as Django admin. And the second reason why lots of people prefer Django ORM is because it's very simple, it's very easy to use. My first ORM was SQL Alchemy, and I switched to Django from it, and to me, Django feels like it's more high level, because there are less things you have to take care of. For example, session management. In SQL Alchemy, you have to do it by yourself. And I also have experience with Alembic and Django migrations, and I just find Django migrations very simple, very easy to use, and everything always works. So, while these two frameworks have some benefits, there's a reason why it's not commonly used. So let's explore some of the challenges it presents. The first thing you notice when you start working with a code base that mixes synchronous and asynchronous code is how often this error message happens. And it happens even in places you didn't really know they exist in your database. How many of you have ever encountered this error message? Raise your hand. Okay, I see around 10 people, so not so many people. If you decide to use both FastAPI, which is asynchronous, and Django, which is synchronous, then you're almost guaranteed to run into it sooner and later. And that's because managing synchronous and asynchronous code adds another layer of complexity that you have to take care of. Let me share a quick story called There and Back Again. When I joined our team a year and a half ago, our code base was sync first. This meant everything was synchronous, except of API routes, because they were FastAPI, which is asynchronous, and we were using their sync to async decorators. Last year, in April 2023, Django has released lots of asynchronous features. So the idea was, now, when we can have everything asynchronous, let's just experiment and try to rewrite the code base and see if an async-first approach makes sense. So my colleague started rewriting the code base, and the change initially seemed successful. everything worked fine. However, the devil is in the details. While Django has released lots of new async features, there are still lots of features that are not there. For example, async transactions. And for us, this was extremely important because we have lots of endpoints where we call different operations, and it's important that they run in a transaction. So for this reason, everything had to be reverted back to sync-first approach. One of the great things about Django is its very rich ecosystem. So there are lots of different libraries which you can use, which is great, so you don't have to reinvent the wheel and create them yourself. However, if you use FastAPI with Django ORM, even though you use Django ORM, you still cannot use lots of these libraries. And that's because FastAPI works in a bit different way. So for example, I tried to use PyTest Django and XGist to speed up tests, and they don't work. And that's because FastAPI uses Starlet's test client, which is a bit different. Some tools do work, but you have to tweak them a bit, meaning they don't work out of the box. When you encounter a problem, what is the first thing you typically do? You Google it. You check Stack Overflow, Google, tutorials, documentation. There are lots of different resources on the internet, especially about Django. There are Discord, servers, forums, documentation, everything. However, if you have any unconventional setup, if you use it with FastAPI, you will not find anything on the internet. So basically, you just have to experiment on your own. And the last thing I want to mention about this combination, this is specifically about FastAPI, and that is that there's only one person who has merge rights. And this is a problem for lots of companies, and this is a problem for lots of people, and a very common reason why they don't use FastAPI in similar frameworks. So lots of people address this problem, and the author replied to them. If I suddenly died being hit by a bus, there are already mechanisms in place for code inheritance. There are others with GitHub rights to take over, etc. But I have requested to still review each PR myself. There have been several cases where there's a PR with several approvals, where no one really reviewed the code, and it had a bug. Because of this, unfortunately, I still prefer to be quite strict about reviewing each PR that is merged. And I think this solution of having a process about code inheritance doesn't really solve the problem, because if the author is not there, then there would be another person who will be still the same person who has merge rights. And when you're planning a project, you're not planning it for 3 months mostly, but you're planning it for years. So for you, it's very important that the tools you are using have some stable organization behind it, that there are multiple people who have the rights. How many of you do know what is Swiss cheese model? Raise your hand. Okay, I see around 10 people, not so many people. This is a model which is often used in risk management, and this is a model which is used in aviation. How do planes crash nowadays? When a plane crashes, it's never because of weather, because planes have been tested in all possible weather conditions. It's also not because of some hardware or software failure, because there are lots of mechanisms how to prevent these as well. And also, it's not because of human error, because it's something also that's been tested. But if an accident occurs, it's because there are multiple factors that occur at once. So you can imagine it as each one of these being one layer. So in each layer you have some vulnerabilities, and in most cases it doesn't really matter. So you can have here, so for example, some user error, but it doesn't matter, because even if it goes to the next layer, it will be stopped. But when there are multiple things that collide, then an accident happens. And this is how modern software works nowadays as well in big and major companies. When there's some huge outage, some big issue, it's never because of one isolating thing that happened, but it's mostly because of multiple things. So my way of thinking about this problem is not like, what if the author gets hit by a bus? But what if the author gets hit by a bus and, for example, there's a security vulnerability that needs to be patched immediately? I don't know what is the answer, but I know that this is a problem for lots of organizations that would like to use similar frameworks. And I also know that lots of organizations appreciate about Django having a stable core maintainers and also having a foundation that's standing behind it. The last point I would like to touch on is the initial setup. If you use Django, you can use commands like start projects and you're ready to begin. Similarly, with FastAPI, you just need a few lines and you're ready to go. But if you have any custom setup, then it would take way more time to set up everything. So how can we set it up? First, let's have a look at the diagram. So basically, we have a FastAPI application, and it utilizes Django ORM for database communication. Where do we start? We are integrating two different frameworks, so we must configure them separately. First, we begin with Django and the database layer. First, we have our settings.py file, which is used in Django. I've changed here only the database name. Everything else remains unchanged. Next, we need the wizgy.py file to import Django settings module and launch the application. Here, we set up the Django settings module called Django Setup and populate the apps with our installed apps. And now, Django is ready. The second part involves setting up FastAPI. So we start by creating a FastAPI app instance. Then we define routes and connect them. For deployment, I prefer using Docker. Here is a Docker file example. Here, we first specify our base image and working directory, copy our requirements, install them, copy all necessary files, expose port 8000, and finally, we launch the app using unicorn. So if we open localhost and type in /docs, we can see the app. Moving on, how do we create an endpoint that lists some data stored in a database? First, we define our endpoint path, add some description, and response model using our Pydantic model. Then, we make a database call, which is wrapped in the sync to async decorator. It's a coroutine, so we must await it. The fetch data is then serialized as a Pydantic model. For Django versions above 4.2, you can use aget directly without the decorator. The implementation basically manages the synchronous and asynchronous code under the hood, so you don't have to take care of it. However, keep in mind that while Django has added lots of async features, not everything has been added yet. And if we call the endpoint, we can see there are some data returned. Now, let's move on to tests. The principle is basically the same as for setting our main app. First, we need to set up Django. First, we define our Django settings module, then we populate apps, and finally run migrations before each session. Because we want the database to be clear for each run, we can create a fixture that truncates all tables after each test run. And then we move on to the second part of our setup, which is the FastAPI side. We create a fixture where basically we just import the app as is. And the last part involves setting up a client to which we pass our imported app and configure its base URL. So let's see how we can create a test. Our test will evaluate the creation of a model. Let's start with unit test. First, we create some fake repository with some fake data, and it might look something like this. So basically, instead of persisting data into a database, we store it in an array which we can access later. We start with creating a request with some data. Then we call our book service, but instead of using its normal repository, we use the fake one. Next, we call the method and pass the request data. And after that, we can access the array where the data is stored. Finally, we can assert whether the stored data equals the data from the request. How about integration tests if you want to test all of your endpoint and you want to use a database? So you could write something like this. First, you need some database fixtures that will take care of truncating tables, setting up the books app, and client fixture. Then we call the endpoint /books, and we assert that the response code is 200. We can also define the expected data and then compare the expected data with the received one. And that's how you could set up tests. So we've seen how it might be implemented, but you're now probably wondering, how about the right structure? If you start out with Django, there is a structure that's already set up for you. And that's because Django is quite opinionated. It was created to promote specific approaches to web development. FastAPI, on the other hand, is very flexible, so you can use it as you want. When it comes to bigger projects, I personally lean towards a module-based structure. It's predictable and extensible. And it's used, for example, in also very big and famous projects like Netflix project Dispatch on GitHub. And this structure works pretty well even if you use Django ORM. All right, so we've discussed some benefits and some challenges of this setup, and we've discussed how we can implement it, but the question is, should we use it together? I personally love working with both frameworks. But if I were to start a new project from scratch, I would first check Django Ninja, as it kind of gives you the best of both worlds. Alternatively, I would also check FastAPI with SQL Alchemy or full Django with Django ORM, depending on project requirements. However, it might happen that you end up on a project which is already integrated two different frameworks together. In that case, I encourage you to experiment, because when things don't work out of the box, you have to tweak things a lot and configure, and for that you have to learn how does it work under the hood. So it's great fun, and also it's a great learning process. And at the end, I would like to mention what my esteemed colleague said when he joined our team during our first retrospective meeting. It's crazy, but it works. I'm Bajić. Thank you for your attention.